Good morning, good evening, good afternoon, everyone, based on your time zone. Welcome in Salesforce FXR. And today topic is extracting microservices from your Microservices org. And our speaker is Jigar. My name is Amit Chaudhary. I'm the founder of the FXR. And before getting started, it's a request from everyone, stay home, be safe, and make a social distance. So before taking any time, let me hand over to Jigar.
Thank you, Amit. So thank you everyone for joining in today. Today we're going to be talking about how you can really extract microservices or adopt that particular pattern from an org, and the general way or general tendency of building building on Salesforce orgs today is to adopt a monolithic pattern. We're going to look at some strategies and tactics, and then at the end of it all, we'll also see a working demo of how this can actually be practically possible. Before that, I just want to make sure that everybody can see my screen. So, yep, hopefully everybody should be able to see my screen now. I'm assuming, yep, okay, nice. So with that, kind of, just a quick introduction about me. My name is Jigar Shah. I'm the Director of Technology at Eternal Solutions. I'm a active contributor on the Stack Exchange as a dev community. I'm also a Dreamforce speaker, 3x certified, co-organizer of Apex Hours and Path to Code, and I blog at learnsftcwithjigar.wordpress.com. Jigar Shah 189 is my Twitter as well as LinkedIn handle. So feel free to reach out to me over these channels, even after this session, if you want to continue the discussion around microservices, or if there's something that you think I can help you with. With that, I wanted to take a moment before I start the session and talk about an important event that's going to be happening on the 16th and 17th of May, and especially given the situation that's there globally right now. This event has specially been crafted, being aware of the situation. It's called as virtual dreaming. It's the first virtual event, dreaming event, in fact, across the globe. It's been founded and run by 3 super MVPs, Jitendra Jha, Rakesh Gupta, and one of them is Amit today, Amit Chaudhary. So yeah, kudos to them for conceptualizing and trying to get this through. There are a lot of amazing speakers that will be present as a part of this event. This event is going to be running across the hours for these 2 dates, and these 3 people whom you see on the screen right now are some amazing people: Kavindra Patel, Leah, and Peter Chittum. So I think these people don't need any introduction. You can, if you want, so I would urge you to please go and register on this website and be a part of this event. There are lots of things to win and lots of knowledge to gain. In fact, there are a lot of CTAs, certified technical architects, who would be taking a lot of sessions. So it's a must attend for anybody in the Salesforce ecosystem. So please do take the time, register, and be a part of this event. Okay, with that, I'll come back to our agenda for today, which is our microservices session. Before I start, I just like to talk about some housekeeping rules. Request you all to keep your mics on mute, and don't shy away from asking questions. No questions are silly. Try to put in your questions in the Q&A window. We'll try to answer all the questions in the last 15 minutes. If in case we are not able to answer your question, feel free to post on the blog against this session on the Apex Hours website, and we will answer your questions there. Right. With that, I kind of just want to start this session. So I've been working with Salesforce for about a decade now, and I've seen the Salesforce evolve as a platform of choice for enterprise, for developing enterprise applications, from a mere CRM to a platform of developing enterprise applications. That's a huge scale and huge growth. Uh, and if I really have to look at uh, the evolution of a Salesforce org across any enterprise that really adopts Salesforce, so it generally goes like this, right? So there is essentially the CRM element that comes into play, which really comprises of the fundamental modules. Everything is generally built around the key standard objects that are part of the fundamental modules of Sales Cloud, Service Cloud, and now especially with the advent of marketing as a very critical function of an organization, Marketing Cloud also has become an essential piece. So that's where all the organizations really start off building their applications on Salesforce, and you know some or most of the once this is kind of done, there is the next jump that these organizations take where they try to customize and add a lot more functionality through the app exchange marketplace, right? They try to use solutions by partners, ready to use solutions, and a common this is where app exchange kind of comes in handy in making that call of buy versus build strategy for solutions especially designed for Salesforce. A lot of these have a lot of organizations have admins, and admins themselves have a whole stash of tools that they can build on, with which they can build solutions for the Salesforce platform. So they use, there are tons of process builders, validation rules, right? And some of, often there is a disconnect between these validation rule, between new declarative functionalities that are built on the production instance, right? Then there's another breed of people that come into play, which is called as developers. They do all the magical stuff with code, end up writing like triggers and lightning components, right? And especially with this declarative stuff being there, a lot of unit tests start failing because there's not a very sound strategy for releasing and building out solutions and releasing them and having them live on the production instance. So unit tests start failing. It's difficult to deploy. And we keep doing this over and over again till till the Salesforce org is a house of cards which is very, very fragile, and kind of crumbling down with every deployment and release. So if you guys see that this is something that you've often experienced with your orgs or your customers' orgs, then you're in the right session, because you've actually built a monolith, right? So basically everything is bundled into one big ball of fire, which comes rolling down and destroys a lot of stuff when every time a deployment happens. And every time this happens, there is a lot of people get mad, whether it is the the architects, the business users. It's a difficult situation, and people start becoming mad, and they often look like this Hulk over here. But when I say mad, I really refer to this term as a monolithic architecture despair, which is often a byproduct of these activities that we do. So it is this, and there are certain drawbacks which come with a monolithic design, right? And let me talk of some of these drawbacks. Why a monolithic design is bad, or what are the challenges that come alongside it. So one of the key things is, in a monolithic design, all the components are extremely tightly coupled, which means that there's a lot of interdependency. Maintenance becomes extremely heavy. Making changes becomes very difficult, right? So when you're that is what I term as a ripple effect, where you try to make a change in one element, and that requires a change in a lot of other elements, right? Which also results in redeploying and deploying of stuff, which again kind of makes the overall maintenance and release cycles extremely heavy and extremely cumbersome. Um, the other thing is, because of such a way of implementation or development, um, you are basically your org is confined to a single stack, which means that scaling of orgs, right, generally kind of becomes difficult. It's always good to have a diverse stack, because there are plenty of other stacks or other tools which kind of complement the efficiency of Salesforce as a platform. And that's where this becomes difficult, especially with the monolithic design. And so these are the general challenges. Now with these challenges, it's often said that necessity is the mother of invention, and that's exactly because of these challenges is why a microservices architecture was born. So a microservices architecture is basically a combination of the layered monolithic plus the distributed service oriented architecture, right? And essentially a microservices architecture is based on isolation, and the isolation is done with the help of things which are known as service components. So if you see right here, a service component is nothing but a combination of modules, which can be a class, multiple classes, and associated objects. Now, if you, in this particular diagram that you see over here, right, uh, the overall platform, the services that are offered are kind of bundled and broken down into individual service components. So there is a tax service piece which only takes care of the tax computations, and it is compartmentalized, very oriented towards uh, you know tax calculation and tax processing. Versus there's a payment service, which is a service component especially focused on the payments aspect, whether it is making payments, refunds, all of that. And then there is an invoice piece which is only associated with invoicing, right? So um, each of these components have a common orchestration layer or a common communication mechanism. And as a result of which, what all these service components do not directly communicate with each other, but are very focused and streamlined on one particular aspect, and use that common channel of communication, right? So this is basically what a microservice is, or this is what the fundamental of a microservice is. Now let's really understand that when you use a typical microservice, what are the key design principles that you should keep in mind in order to build out a microservice. So let's look. So just like you have the solid principles of design, enterprise architects or when you do architecture, there is often this solid is an acronym for the principles of design. Similarly, there is an acronym that I framed especially for which outlines the principles of microservice design. So these are the principles which act as guiding lights for you to design a microservice when you are trying to do that for your org. So let's understand what these principles are. So one of the first thing is microservices are basically designed for resilience, which means that they are designed for failure, and they have an inbuilt mechanism or strategy to bounce back from failure without really affecting the state, and also having a strategy for uh, data to be resurrected when the failure is kind of when basically the failure is kind of overcome, right? In fact, a lot of organizations that use microservices architecture, companies like Netflix and Amazon, they often um, perform conscious failures, often instigate failures just to ensure that their services or their architecture is resilient to failures, and everything works as desired, especially from a failure and recovery standpoint. The next principle is there is a lot of and it's which is a key principle of microservice design is orchestrated communication, basically. So like I mentioned earlier in the previous slide, there are a lot of see, microservice comprises of a lot of decoupled units, right? Which are typically termed as service components. And each of these service components do not interact directly with each other, which means there has to be a very streamlined mechanism to communicate, which is basically what I'm referring to as orchestrated communication right here, right? The next and another key aspect of microservices design, which kind of helps overcome the challenges of a monolith architecture, is that it is loosely coupled, which means there is low interdependency between the components, because they're all, each of the component is very, very focused towards a specific purpose. And hence, it kind of reduces the toll on maintenance, and maintainability of microservices is very high as compared to a basic monolithic architecture where everything has extreme and high interdependence between each other. And in order to achieve this loose coupling, there is a specific isolation. Isolation is generally done in the context of a process which truly defines the purpose of that microservice. And that is again a key element in the microservice design. And last but not the least, especially with the microservices design, you design it such so that you can scale it and really leverage a diverse technology stack, as compared to just being able to use a single stack in a monolith. So this is how, you know, your principles of microservice design. So anytime you write a microservice or really design a microservice, these are the principles that you need to keep in mind in order to ensure that that, you know, your service that you're writing kind of complies with these principles. Okay. With that, let's talk about, so today's session is not only about, you know, how to build a microservice. I think it is about more about strategies and tactics that we can look at in order to extract or look for areas where a microservice is possible. Okay. And that's what I really, so I've kind of compiled a recipe for, you know, being able to extract or identify potential areas for where microservices can be implemented in your org. So, you know, that's what I call as the microservice identification secret sauce, right? So let's start with individual principles of this secret sauce, and we will understand how to go about identifying areas and, you know, extracting those microservices on your org. So one of the first things is, whenever we, you know, kind of talk about any such thing, I think there is a common question that comes to everybody's mind is, where should I begin, or how do I start looking for places, potential areas for microservices, or which can be converted into microservices? And that exactly is what we address in this with this first ingredient. And this is based on a term called as hot objects, which essentially is coined by Stephen Rod. He's a Salesforce MVP and a certified technical architect. And often in your orgs, there are hot objects is basically a term which kind of talks about specific objects. And often in your org, you will see that there are certain objects which require a heightened level of effort in terms of design, making changes, or, you know, building anything around that, those objects. And, you know, just to give you a very quick example, there are objects such as, you know, accounts, opportunities, cases. You know, these are just some of them. You know, these could be custom objects, these could be standard objects, but these are those heavily utilized objects, and they are very, very few. They could be, you know, probably just in single digits, but these are some of these objects which is a great place to start extracting microservices, especially because of the high convergence in terms of process, and, you know, there's a lot of interdependency that's built. And you know, some of the ways in which you can really look and search for hot objects is based on the peculiar traits that they exhibit, right? So if, you know, there are often objects, or some of these objects, hot objects, which we call them as, they'll have really high number of fields, like maybe 500, 400 plus fields. You know, the moment you start looking at such objects, you kind of realize, and that should ring a bell, that these are objects which basically looks or falls in the hot object category. They're extremely heavy on automation, lots of process builders, lots of triggers, um, lots of data in there, millions of records. When you see at least two out of these three traits, you know that this is basically a hot object, and this is exactly which is a great uh, point to start looking and start trying to extract your microservices. So uh, hot objects is where you should typically begin looking for that, right? The second thing is, now once you've identified where you should start, how should you go about doing it? Like, what is the strategy that you should kind of employ, right? And there are basically two strategies that I can kind of recommend or that I've come across. um, and these strategies are basically essentially bucketed into two categories. One, which is purely about for nascent orgs, like there are orgs which are not extremely matured, don't have too much of data, do not have too many objects, but have a lot of less processes, a lot of less users. And this strategy, I call it as COFI, which is which is an acronym for core first. So if you really look at trying to extract microservices, there are a lot of, the reason why a monolith is built is because there is heavy interdependence between each of the entities there, in terms of processes, in terms of code, in terms of objects. And that is what is a killer, and that's the whole point of how a monolith comes into play. Now, in order to execute a core first strategy, what you really start doing is you start stripping out the core object first, which is, or the core entity first. So in this particular example, like, opportunity is the core entity and all these are ancillary entities. Now, the reason why I said that this kind of strategy works for nascent orgs is the business impact is relatively high when you pull out the core object and try to restructure, rewire that as a microservice, right? And although the time taken is relatively low, because the moment you kind of strip off the core entity, right, and try to put it in as a separate service component and restructure it, rest of this components would automatically fall in place, right? So this kind of an impact is generally okay with really nascent orgs and not very heavy interdependency, and not do not employ a global usage or do not have a global set of global user base. But if you really have an enterprise org which is extremely heavy on customizations and hundreds of thousands of users across the globe and all of that, then this strategy will not work, because this is has a really heavy impact. In that case, you can go using a core last strategy, which is basically a good fit for matured and complex orgs. So what you really start doing is you start stripping off the ancillary processes and try to turn each of these into a microservice or a service component, right? And this is an iterative process, which means that it is time taking, right? But the impact is minimal, which means that with orgs of such scale, I believe that this is a great way to kind of restructure your overall monolith into a microservice. So this were some of the isolation strategies that can be employed to kind of convert a monolith and try restructuring it into a microservice. Now, that being said, so you figured out where to start, you figured out what strategy to employ. One of the key things here is also to understand how do you decouple your implementations, right? From an implementation perspective. And here I think that's where some of these best practices come into play. But there are very specific things I would like to mention over here, which are extremely essential in building out a microservice and trying to ensure long-term maintainability for the microservice. One of the first things is I would strongly recommend using is using the separation of concerns pattern. So for people who don't really know, separation of concerns is an enterprise application design pattern, right? And it comprises of three basic, kind of dividing your architecture, or especially this is relevant for code, and kind of breaking down your code into three basic layers. There's a service layer, there's a domain and selector layer, and then there's a database layer, right? And it also employs a unit of work strategy, and we'll talk about that in a minute. But the whole idea is to kind of compartmentalize the responsibilities, and separate them, into respective layers. So basically, all your business logic really, exists as a service which can be called or invoked in a reusable fashion across all these entities which are capable of invoking that service. This kind of reduces maintainability and reduces interdependency. So this is there's a great tailored module around this, right? So I would recommend people to try that out. But yeah, this is one of the key things in helping you build out your microservice. And of course, there is a unit of work pattern, and this unit of work pattern is really implemented well with a library which is already existing. There's a Financial Force Apex library, right, which implements this unit of work pattern. Basically, the whole idea is you kind of compartmentalize your transaction into smaller pieces of or smaller units, which are termed as units of work. And there is a very conscious focus which they offer around this. So how do you accomplish this? So this is done with these two methods which are a part of these library, which is register new and commit work. So register, so basically there is an internal data structure which is leveraged. So what in order to perform DML operations, right, what this library helps you to do is control them consciously and only perform DMLs at the end of a transaction. So all the changes are kind of held through in an intermittent data structure which the library offers. So you really all that complexity is abstracted, and all you have to do is just make calls. Every time you make a change to your in-memory data structure, you just call the register new method, and at the end of it, when you really want to commit this changes to the database, you call the commit work method, and that does all the dirty work for you. Additionally, there is also always a focus on trigger frameworks. So I'm not sure if a lot of people have heard about it, but it's absolutely recommended that you start following trigger frameworks when you write trigger code, and there are multiple frameworks that you can leverage. In fact, we have another session which is already there by Adam, which talks about what are the trigger frameworks and how you can really leverage them. So this is the strategy, or these are the three things which you once employ can really help you decouple your implementations and implement or get the whole element of isolation within your service components. Okay, that brings me to my next principle is, once you identify where to start, what strategy to employ, and how what architectural pattern to leverage to decouple your implementations, you got to look at tools which are available for decoupling. So as a result of that, because Salesforce being a platform where clicks are as important as code, it's good to maintain a balance between the declarative and programmatic artifacts you build. So tools for decoupling are available in both these flavors. They're available as declarative tools as well, and they're available as programmatic tools as well. So especially in a declarative format, there are process builders and there are platform events which you can leverage. For programmatic tools, there are things called as invocable Apex. So invocable Apex is nothing but methods that can be invoked from a process builder. We'll see in a bit, how you can write a simple invocable Apex method and leverage it for decoupling. REST services, Salesforce has a service-first architecture, which means that all the functionalities, at least most of the functionalities that you leverage via the UI or the web-based interface, are also available as REST and REST services or SOAP services, which you can leverage across the IT landscape for collaborating Salesforce information with other tools. And of course, there is Heroku, which allows you, which is an IaaS, infrastructure as a service, allowing you to port your Java and Ruby programs, and write a lot of complex processing microservices. You can really host them on Heroku. Process Builder, everybody knows, it's a declarative tool, rule-based engine, which allows you to perform manipulations. And platform events is nothing but an event-based architecture that Salesforce provides. Basically, with platform events, you can really employ a publisher subscriber based architecture, right? It's a message based communication, asynchronous communication that can be leveraged. So in our demo today, we're going to be seeing some of these artifacts that can be leveraged and how you can really build a microservice using these ingredients right here. But these are some of the tools that can be leveraged for decoupling your implementations. Last but not the least, I think an important element of isolation is the ability to perform changes and is the ability to test them in isolation. Often today when you write code, there is a heavy interdependency between the entities, right? And that's what kind of makes it difficult to deploy, and that's what causes a lot of interdependence. So there is something called as stub provider, right, which is basically a mocking interface provided by the Salesforce platform. So what you can really do is the test classes that you write, you can actually use this mocking interface to mock the responses or outputs of your regular test case implementations, right? The reason why this kind of is very important is because it gives you the flexibility of testing your functionality in isolation. So for example, if you go back to that earlier slide where we had multiple components, there was a service component, there was a payment component, a tax component, a payment component, and invoicing component, right? So with this pattern, I can really, it's a kind of black box testing where you provide the parameters and the actual value, and it kind of tests it. And the way this works is your apex test method really makes a call to the mock object, which in turn makes a call to the stub provider via the handle method call, right? And you need to provide a set of parameters. There is a method name that you provide, you give a combination of parameters, and it just returns the output for certain conditions. And especially when you're trying to use this pattern, it really enforces you to go to adopt a test-driven development sort of a methodology where you kind of end up writing the test code before the actual implementation. So this kind of gives you greater ability to make sure that your code that you're actually writing kind of complies with the actual use cases, right? So a great way to really test your changes in isolation. So these are some of the key ingredients or methods that can be leveraged in actually building out microservice on the platform. With that, I kind of want to just showcase or show you how you can actually build a microservice with all these principles and things tools that we've talked about. So here, there's a demo that I've churned up for you, which is revolving basically around a hypothetical organization called WealthForce. And WealthForce is a financial advisory service provider, and they provide this service as on a subscription model where people can pay annually, monthly, half yearly, quarterly, based on their subscription model. They would be charged a certain fee based on their payment frequency. So let's just talk a little bit about the use case, and we'll also see how what is the solution using microservices, and then we'll actually see the microservices in action. So the use case here is that a customer has been using the WealthForce service, and for some reason he's not happy, and he raises a request, maybe through a mobile application or an external application. This request kind of comes to Salesforce, right? And once a cancellation request comes in, there's a typical process that happens behind the scenes. There is an actual cancellation of the subscription. Okay, for demonstration purposes, I've kept this really simple. In the real world, I'm sure cancellations, there's a lot of complexity to this, but just in order to demonstrate here, there are very fewer steps that I've kind of included here. So there is a cancellation of the subscription, but there is also a processing of the refund, especially because it's a subscription based service. There is proration and there will be refund that will happen. Now, and the customer is kind of notified in some form or the other, right? Now, with this being said, if this is the use case, how would you kind of implement microservices to kind of address this use case? So what we are really doing is the customer raises a request. Our solution here is we're using REST services available from Salesforce in conjunction with platform events to raise the cancellation request. That in turn, kind of triggers a process builder which invokes some kind of business logic written in Apex, which uses invocable Apex classes to perform the calculation and process the refund. And once that is done, it kind of splits this or makes a call or sends a notification out in the form of another platform event, which basically leverages another process builder and performs a chatter post, right? So the notification is generally being sent out through chatter for this particular use case here. So what you really have is, one block here, which is typically around only canceling subscription, then processing refunds, and the other which is purely around notification. So these are two microservices that you can build, which are a part of a bigger use case, but are entirely focused in very, very isolated service components that cater to specific pieces of this bigger use case. So what I'm going to do now is I'm going to switch over to my Salesforce instance and quickly see these things in action. So okay, so this is a Salesforce org, demo Salesforce org that I have set up, right? And let's just go through our recipe first. So we talked about platform events. So we're going to be using platform events right here. So these are the two basic platform events that I've created. Platform events are basically message packets, and they really look like objects, right? You can really define custom fields which define what content is really being leveraged in this particular platform event. So I've created two platform events. One is basically which basically encompasses the request for canceling of the subscription, right? One of the peculiar things about platform event is they end in a double underscore E, as opposed to double underscore C for custom objects, right? And for simplicity, I have only a single field. In the real world, your cancellation platform event may have a whole lot of other information that kind of will be sent. In this case, I'm just accepting a customer ID for which this cancellation request needs to be raised, right? And then I have the notification platform event, and this event is basically raised for sending out notifications, so that if tomorrow the notification not only needs to be sent out to through chatter, but also through other mechanisms, this notification platform event can be leveraged to subscribe to that, and there can be further processing which can be done. So so this is one of the pieces. The other pieces that we are leveraging over here is is process builders. Let me just quickly my internet is a little slow, so I'm sorry if it's taking a little bit of time to load things over here. Okay, I'm just quickly going to go and refresh the page. Hopefully that will make things better over here. So these are two process builders that I've written. These process builders are listening to these platform events, and what these process builders are doing is this first process builder right here is kind of listening to the cancel subscriptions platform event, and based on this condition, it is kind of making, performing a call to update the date, right? And it is also making a call to a Apex class, which is the cancel subscriptions process handler, which is really responsible for performing the proration cancellation and really stamping out the refund fee if there is any, right? So this is what this particular process builder is doing right here. Okay, I'm going to go back and also show you the other process builder. Okay, go back and say process builder. This right here is basically a publish notification process builder, which is subscribing to the notification platform event, right? It's listening to the platform event, and then it's simply posting content to Chatter. It's templatized content that we are posting, right? So this is basically, these are some of the ingredients. Let us also look at some of the pieces of code that have been written over here, right? So if you recall, the initial process builder that kind of listened to the cancel subscription request was making a call to the process handler right here. So this is a service, an initial handler that is written, and this is used in conjunction with the help of an invocable method. You're able to pass the list of customers for which the cancellation request needs to be initiated, and in turn it's making a call to the service method, which I am trying to, the service method is written in compliance with the separation of concern pattern, right? And there's a service class that has been written for this particular subscription activity, cancellation activity, and it has cancel subscriptions method. This method is basically retrieving the records, so subscription record, right? And then it's kind of setting the flag for that respective subscription to false, which kind of signifies that the subscription is cancelled, and the refund amount is prorated based on the month, right? So this is a simple thing, and then there is a basic call that is performed, right? I'm not explicitly using unit of work, but this is actually where a unit of work would kind of come in handy. So this is how your actual subscription and things are getting calculated. Now, in order to demonstrate this, I'm going to be using a workbench. Workbench is a tool which allows you to do a whole lot of interactions and activities with your Salesforce org. And I'm going to be using the REST Explorer right here. So if I kind of switch back to my instance, the customer is kind of going to raise a request through the REST interface, right? And that is eventually going to invoke a platform event, and that is going to result in the cancellation of the subscription, processing of refund, and eventually post a notification on Chatter. So right now in my org, let me just quickly open up the application. So I have a WealthForce app right here, and this app is having member records, right, which are nothing but account records, and each account is having a subscription right here. So I'm going to go and look at Frank Gallagher's subscription record, right? And this subscription record right here is active, and it has a certain fee that it is there, and it has an individual customer ID. Because there's no cancellation requested at this point in time, there is nothing, there's no date stamped for cancellation request, and there is no refund amount. Once we request the cancellation and the entire processing happens, this record should ideally be set to, should be deactivated, and the date should be stamped with today's date, and the amount should be calculated based on proration of the actual subscription amount, right? So let's just go ahead and see how this can be done. So I showcase to you the building blocks of what is, how we have really constructed or structured out these microservices based on some of the principles and the tools that we talked about, right? So let's just see all this in action now. So I'm going to go back to the workbench. I'm going to make a simple post call, And for simplicity, I'm going to use the REST call, right? So for people who are not very conversant with platform events are also available as REST services, right? So you can actually raise platform events even through external um, applications. So what I'm going to use Workbench is to emulate the mobile application through which the customer is raising a cancellation request. And because he's raising a cancellation request, he's going to go and share some information about him. And that information is going to be the customer ID, right? Because that is what um, our engine here needs, or our microservice needs to kind of compute or process the cancellation and refund. So what I'm going to do here is simply go and do perform and execute and perform a post call. So this here kind of tells me that the request was processed successfully, or the request was raised successfully rather. Now let's actually go and look at the record. Now, because this employs platform events, this might take a while to reflect, but we'll see that. So this is actually the state of the record before the request was raised. Now actually go back and see. Let me refresh this the record, and hopefully if the event has occurred and everything has gone through. So you see that the cancellation date was stamped to today's date, and the refund amount was processed, and the subscription status was set to active. And there was another uh, microservice that was invoked after this got processed, was to post something on Chatter. And you see that there is a Chatter post that happens, which kind of notifies that this subscription for a certain account was canceled, and this is the proration amount. So which can be used to notify other people in the team who can then take on this. Maybe like an accounting team or finance team who can take. And this can be extended to sending emails or sending out notifications to other applications. But this is how you can really isolate the responsibilities and truly design microservices for your org. I'm going to quickly switch back to my presentation here. And this is how you can actually build a microservices for real world cases. I'm sure real world cases are going to be much more complex, but the same strategy applies there as well. Quickly before I end, there are certain considerations that I would request everyone to keep in mind before trying to adopt or go the microservices route. Like everything has a limitation. Microservices is not the silver bullet to every problem, right? Every architectural problem. There are certain considerations that everybody should employ. So one of the key things where microservices really scores poorly is the kind of complexity that is involved in implementation. So if you really think of adopting a microservices architecture, look at the time frame that you really need to cater to, because the microservices are inherently complex to implement. And that is one of the areas where Monolith really scores over microservices. If you really have less time and if it's not too very complex, you might consider a monolithic architecture, right? But there are areas where you have long-term benefits of microservices, which is typically fault tolerance, because it's designed for resilience, and because of the low interdependency and a lot of loose coupling between the components, service components, the maintenance really becomes a lot more easier. And of course, with the way services are built out, you can really leverage multiple tech stacks, and scale your application, which is where the monolith falls short of. So I think with that kind of brings me to the end of this session. I would strongly recommend some of these additional references, which I have also referred. And in fact, I would recommend everyone on this attending the session today to try to go through these two trailheads, which basically show you how to write Apex enterprise patterns, which is the separation of concern pattern in detail. They talk about the service layer and the domain selector layer. And of course, there's a great blog on hot objects and separation of concerns from Andrew Fawcett. And about, if you want to know about software architectural patterns in general, this kind of is really valuable. So these are some great references that you can refer to even after this session and get more hands-on. I think with that, I just kind of open up the floor for questions. So I know that there were quite a lot of questions. So I'm going to just pause my share for the moment and quickly go and look at the questions and see if I can, we can take the opportunity to answer a few of those. Okay, I'll probably start is when you say a microservice is there's a question from Adrian, which is basically, what do you mean? What is the precise definition of microservice? So microservice is basically nothing but an architectural pattern, right? And it is basically set, isolating the key aspects or key business logic into individual isolated elements that can operate on its own and communicate with each other through a very structured, orchestrated communication, and can be extended to an external stack. So for example, if you had a mobile application and you had other things, or services that you wanted to connect to or really talk to, or if you had a Node.js application that you wanted to interact with some of these services, microservices, you can do that with ease without really changing too many things. So that's what I would kind of define as a microservice, right? And that kind of also answer the question from Gaurav, which is span across technology stack, which means that you could have an application built on mean stack or a lamb stack, or some open source stack, and that kind of is capable of, or is part of leveraging, is not only leveraging, but can be a service component in that entire microservice piece. So that's what I truly meant by a diverse technology stack. There's a question from one of the people which says microservice has resilience. How do we make sure microservice has resilience? So that was one of the reasons why I kind of also leveraged platform events, because that's an important link in building out a microservice, saying that how do you build fault tolerance. So fault tolerance can be done in certain ways, especially my whole idea of using platform events here to build out the fault tolerance was, even in case of an issue, events kind of stay in the bus throughout, for a period of about 3 days, which means that for any service going down, you can kind of really use the replay function of the platform events to kind of um, bounce back from the failure, and really without any loss of data. So that's how you can typically implement fault tolerance. I'm just going through and skimming through other. How do you invoke platform events from UI like an Aura component? There are quite a few ways of doing it. You can use one of the things that you can use is change data capture events. You can also directly listen to platform events from your UI, because at the end of the day, your Aura components can really make calls to Apex, and you can really use subscribers, right, Apex triggers or process builders to listen, and then kind of use that. So you can basically use CDCs, because CDCs also internally use platform events. So there's a question which says, how does service-oriented architecture differ from microservice architecture? I think this is a long-standing discussion. A lot of people believe that microservices are not very different from service-oriented architecture. To me, microservice is kind of a combination, like I mentioned, of the distributed service-oriented architecture and the layered monolith. So it's kind of a subset of SOA, but slightly different in terms of the way SOA is versus a microservice is. So there is one question which kind of talks about deployment issues, or she's talking about, say that how from a deployment standpoint will a microservice help. The whole point is, with microservice, the components are isolated, which means, everything's very loosely coupled. So when you really deploy, you're only deploying that aspect of the application and that particular microservice. So even when you're making changes, or making enhancements, the changes are made to that respective microservice. So what you end up doing is the change is not propagated across the other services. If I just go back and take the example of, the earlier service sample that was there, which comprises of a tax service, a payment service, and an invoice service. So tomorrow you have changes to to something which is associated with invoice. You would only have to deploy and make changes to that aspect, which means that your other services don't really have to go down, and they work as usual, which means there is a whole lot of low interdependency or no interdependency. It's only dependent on in that respective microservice. So that's where, from a deployment standpoint, it really comes in handy, where the impact of the deployment is extremely low in case of a microservice, right? Okay, I think that was pretty much it. Amit, I think that's it probably.
Yeah, Jigar, thank you so much for a great presentation, and thank you everyone for joining us. We will share the recording on our YouTube channel at Salesforce FXR. So subscribe our channel and wait for the notification so that whenever the recording will be available, you will get a notification. With that said, I will say stay at home, be safe, and take care. Bye-bye.
Yep. Thank you, everyone. Hope you guys all, stay safe and keep learning, and feel free to reach out and post comments and questions on our blog, and we'll be more than happy to answer. So thank you, and thank you for being so patient throughout the session. So thank you once again.
Thank you, everyone. Bye-bye.